Hi everyone, in this video I want to talk about the concept of independent, identically distributed random variables. Concept is independent, identically distributed random variable. Okay. Random variables. Usually we just call them IID, right? So independent, identically distributed. We just call them IID random variables. Now let's talk about each single term and what it means. Independent. The term independent means each outcome not related to previous or next outcomes. Okay, so imagine you have a random variable and then you just keep getting outcomes and keep getting realized value from this random variable or from this distribution, right? And each single outcome, the way you get it, and it's not related to the previous one, and it's not going to affect the next one. So each single time you pull from this random variable or this distribution is independent from the previous one and the next one. That's what it means to be independent. And then identically distributed, what it means is that the outcomes you get are from same or all the outcomes are from the same distribution. Okay? So in a word, it's just that they're from the same place, from the exact same place, same distribution that you pick out your outcomes. So each outcome don't affect each other. They're from the same place, same distribution. That's what we call independent, identically distributed. Let me give you an example. So example, you roll a die twice, okay? And the first row and the second row, the first outcome and the second outcome are IID, right? The first row and second row are IID, right? Independent, identically distributed. Because you roll a dice once and first time, second time, the first time does not affect the second time, and the second time does not affect the first time. They're independent. And then they're from the same die, so they're from the same distribution. They're from the same place, right? So these two are IID. They're independent and they're identically distributed. Okay, good. And how this concept can be applied. Let me give you an example. And this example has a name, additional root. Additional root. Say I have x1, x2, x3, all the way to xn. Each one is an outcome from a random variable, from a distribution, right? Each single one. And their IID. Let's say the IID, they are IID, right? I pick one, and then I pick another one, until I pick n of them. What is the expected value of the sum? Okay, right? And we know that for expectation, you can apply them linearly So this equals to the expected value of x1 plus the expected value of x2 plus all the way to the expected value of xn, right, of n of them. So until now, we did not use the concept of IID, but next we are going to use the concept of IID is that because each single one are from the same distribution, right? Same distribution means that they will have the same expected mean and they will have the same variance. So each single outcome, expected value of each single possible outcome is equals to mu of x, right? Mu of x. They are the same because they're IID. They're from the same distribution. And the total n of them. So this would just equals to n times mu x, right? The reason we can do this is that they're from the same distribution. Okay, they're from the same distribution. Right, that's why they're all equals to mu x. Okay, very good. Next, let's do the variance. Okay, variance of x1 plus x2 plus all the way to xn. Okay, and this equals to, right? Remember the formula, we have x plus y, but now with more. So in theory, we should have variance of x1 plus variance of x2 plus variance of xn, and then we have to worry about a bunch of covariance, but covariances, right? We should worry about the covariances, but then because they're IID, that means each single one are independent to each other. Remember, if they're independent, then their covariances are going to be 0, right? So this one go away 0 because they are independent. Oops. Let me write it better. They're independent. Okay, they're independent. And what's special about these, right? Again, they're from the same distribution, right? If they're from the same distribution, each single variances, they are going to be the same, right? They're all going to be the same. So this equals to sigma square plus sigma square, and there are n of them again. There are n of them. So this will just equals to n times sigma x squared. Okay, and that's the variance of all n possible outcomes or n possible drawers from the same distribution. And again, the reason is they're from the same distribution. Okay, and then the standard deviation is just the square of this. So the standard deviation of x1 plus Sn equals to square root of n sigma x. Okay, and that's the standard deviation of xn plus all the way from the SC of x1 plus x2 all the way to xn. This video concludes the concept of independent, identically distributed random variables. Thank you for watching. I will see you in the next video.